Good morning, everyone. My name is Jack Cable. I am a senior technical advisor at CISA. That's the U.S. Cybersecurity and Infrastructure Security Agency. And we lead the nation's effort to manage and reduce risks to both our federal government and critical infrastructure. And today I'm going to be talking about our approach to how we are helping to secure the technology ecosystem, including open source software. But before we get into that, quick show of hands, anyone here recognize this car? See a couple hands, okay. So this is the Chevy Corvair, and it's perhaps most well known for its inclusion in Ralph Nader's 1965 book, Unsafe at Any Speed. And this car would sometimes get into what was known as a one-car accident, where sometimes, you would be driving and you might make a quick turn and the car would randomly just flip over. And this car was so unsafe that other companies made products to try to make the car a little safer to drive. So we have products like this. This is the camber compensator and was advertised to do amazing things like keeping both wheels working when cornering or driving in gusty winds because you didn't get that out of the box with the car. So this seems pretty crazy today, and we might even take for granted the level of safety that comes built into cars today. We don't have to worry about our cars flipping over because auto manufacturers have, over time, shifted to prioritize safety and security of their customers. But this wasn't always the case. And really, even, say, 50, 60 years ago, when Nader wrote that book, the conventional wisdom of the time that car accidents were the fault of bad drivers, that they simply had to do better, that car manufacturers couldn't possibly do anything to make the cars they were creating safer. We know today that isn't true. We know there can be things like airbags and seat belts and anti-lock brakes that can significantly contribute to the safety of cars. And indeed, we've seen quite remarkable improvements in auto safety over time. So this is a graph of auto safety over the past 100 years. And we see something quite remarkable, that even as the number of miles that we've driven on roads has increased over the past century, not only has the rate of deaths gone down, but even the total number of deaths has decreased quite dramatically. And this wasn't an accident. This was due both to voluntary action by the car manufacturers and regulations that brought upon us safety improvements to benefit all of us. Okay, so why is this guy from the government coming to this conference talking about cars? I promise I'm at the right place, because I want to ask you, how does the software industry stack up? And the reality is that basic preventable classes of vulnerabilities continue to cause damaging cyber attacks. This can be from nation states, like some of the attacks that CISA and other agencies have been warning about, originating from the People's Republic of China, or due to ransomware attacks from a variety of cyber criminals that are wreaking havoc on school systems, hospitals, small businesses, you name it. These are basic vulnerabilities that are fully within the power of technology manufacturers to prevent. For instance, the largest ransomware incident of 2023 was caused by a SQL injection vulnerability. We've had parameterized queries for about 2 decades, and yet we continue to see these basic vulnerabilities being used to cause harm at scale. So how can we do better? How can we get to a place where we no longer see these basic vulnerabilities causing harm? I think that it is possible for the software industry to do better. We can look to countless other industries like the auto industry, like the aviation industry, to see that other places have undergone these radical transformations. At the time it felt radical, now it just feels like common sense. I don't think software is any different, and if we do want a future that is more secure, we're going to have to believe that. So where are we today? Well, certainly there's a lot of burden that falls on end users of software products. Whether it's having to buy security products just to use the products you're using securely, or pay extra for basic security features like logging or single sign-on, we do not make it easy for end users of technology products to use the products that they're buying securely. And it shouldn't be on them, because why would we expect end users to be able to protect themselves from these very sophisticated adversaries when the manufacturers of these products could be doing significantly more to protect their customers. So to this end, the White House released the United States' National Cybersecurity Strategy in March of last year. And this called for a fundamental shift in the burden of cybersecurity, to shift it away from those least capable, whether individuals, schools, critical infrastructure, to those who are most able to bear it. And namely, that's these technology manufacturers who are building products underpinning almost every facet of our daily lives. And to that end, back in October, CISA, along with 17 US and international cybersecurity agencies spanning the Americas, Europe, Asia, published our guidance on what we call Secure by Design. And with Secure by Design, we are laying out how technology manufacturers can do better, how they can prioritize the security of their customers to benefit us all. And in particular, we call out 3 Secure by Design principles that we want every software manufacturer to prioritize. And these are business principles because it is our perspective that while it is not easy to build a product that is more secure, we do know how to eliminate common classes of vulnerabilities. We're not asking for a perfectly secure product, we're asking for something that is more resilient to common classes of attacks. So the first of these principles is to take ownership of customer security outcomes. We know that tech manufacturers must view the security of their customers as an extension of their own. The second is to lead with radical transparency and accountability, to be open about their successes and failures in security. And third, to lead from the top, recognizing that it is up to the business executive leadership of these companies to drive these changes within their organizations. So we've been working to drive this adoption among tech companies. We did a pledge where we have about 230 companies, including the world's largest, who've committed to demonstrating measurable progress in 7 areas to increase the security of their products for their customers. But what I want to talk about today is what lies at this intersection of Secure by Design and open source software security. Because it's our thesis that in order to bring these security improvements to the open source ecosystem, we can't just rely on the individual developers, the people who are donating their time to help sustain this. We need the companies who are profiting and benefiting significantly from open source software to help sustain those open source ecosystems and communities that they are benefiting from. So we call on every software manufacturer to be both a responsible consumer of the open source software that they're using, as well as a sustainable contributor back to that open source software. And to that end, we want to be doing our part at CISA. So last September, just over a year ago, we published our open source software security roadmap. You can go and read this on our website. That laid out 4 goals for how we are working to help secure the open source ecosystem hand in hand with the open source community. The first of these goals was really to build out relationships with the open source community, recognizing that government, at least the US government, has not played a significant role in the open source community in the past, and that our role should not be to show up and try to control or regulate open source, but rather to show up as a community member and contribute where our resources allow us to. So to that end, for instance, we held a summit back in March with about 50 open source community members spanning open source foundations, package repositories, individual contributors, and so on, to talk about how we can progress around security. One of the things we did there was we held a tabletop exercise responding to what at the time was a hypothetical vulnerability in an open source component. Wound up looking somewhat similar to the XZ compromise that happened about a month later. And we heard that that exercise was useful in helping prepare for that. And we were then able to leverage those relationships we had to facilitate real-time sharing of information as XZ unfolded so that the community could help, for instance, respond to other similar sorts of attacks. So that's the first goal, build relationships with open source communities. And I want to emphasize that part of that means that we are bringing people with open source expertise to CISA. So for instance, two people some in this room might know, Ava Black and Tim Pepper, are now at CISA helping lead our open source security efforts. Both of them have decades of experience in open source communities. Okay, so the second goal of our roadmap is to understand the prevalence and measure risks associated with open source software both federal government and critical infrastructure are using. Because we know we can't manage and really acknowledge the open source software that we're using unless we have a solid understanding of what that is composed of. So we are working, for instance, to look at operational technology and see what open source packages we are most dependent on. And then we want to have a sound way of, once we know what open source software we are using, to measure and understand, for instance, are there repositories we should be contributing back to more? Are there repositories that we might want to consider alternatives to? Goal number 3 is around reducing risks specifically to the federal government. And one of the ideas that we've seen gain a lot of traction in industry is this model of an open source program office as a way to manage an organization's use of and contributions to open source software. We think this is something worth trying in government. There's already one federal agency, Centers for Medicare and Medicaid Services, they might be here today, who has established an open source program office. We are also working on doing one at CISA. But we think this is something that has tremendous potential to enable federal governments to better use and contribute to open source software. Lastly, around hardening the open source ecosystem, this is an area where we want to work with the open source community to see how we can contribute to secure the broader ecosystem. One of the actions we've done here is recognizing that package repositories are at a tremendous point, both in terms of their scale. Virtually every developer is using them to download open source packages, and many of these repositories themselves are resource-constrained nonprofits. So we wanted to see how we could help lay out roadmaps for security, recognizing that actions like multi-factor authentication can help protect repositories on their platforms from compromise. So we worked with the Open Source Security Foundation, the OpenSF, to put out our document Principles for Package Repository Security, which lays out a framework for steps that package repositories can take and a maturity model for the security of their platform centered around 4 areas: authentication, authorization, general capabilities, and CLI tooling. And through this, we announced at our summit we held in March actions that 5 major package repositories, NPM, PyPI, Crates.io, Maven, as well as Composer, are taking to secure their platforms in line with this framework. Okay, so I know what you're thinking. It's about 10 minutes into this talk, and I haven't mentioned AI once. Maybe you're relieved, maybe you're a little worried, but don't worry, because here it comes. I want to talk about something that I know is a hot topic at All Things Open this year, and that is open source AI. In June, CISA published our response to a US government request for information on open foundation models with widely available weights. And in our response, we emphasized that open source AI models can allow for tremendous innovation, and they can even help benefit security. But the thing is that we need to recognize that while, say, releasing models with widely available weights but without training data is great for innovation, and we should continue to encourage this, it does not allow for the full level of transparency that is associated with open source software. And my hope is that this community can work together to define a model that accounts for tiers of openness with things like source code and training data and model weights, recognizing that just like with open source code, we wouldn't consider releasing compiled code alone to be open source because that doesn't fully allow for that code to be understood, studied, and analyzed for vulnerabilities. Fully open source AI models need to include access to things like training data as well as model weights and source code. So we should continue to applaud any level of openness, but we need to be transparent about what level of transparency is included when a model is released. Okay, And now I'm sure you're dying to know, how can you help out? How can you get involved? Well, one, of course, I hope that everyone here will go and evangelize secure software development in their communities, and we've put out some good guidance on secure software development. But again, we know that at the end of the day, it is going to be up to the companies who are building products who are used by billions of people. They are the ones who really need to take ownership of their customer security outcomes. And to that end, just 2 weeks ago, we published a document called Product Security Bad Practices. And this document is open for public comment. You can scan that QR code to go and check it out. I think it should be big enough. But what we did in this document was we laid out actions that we, as well as the FBI, view as unacceptable in software development for commercial products in 2024. And this includes things like developing new product lines in memory unsafe programming languages, like providing raw user input in the contents of a database query or an operating system command, as well as not having a published vulnerability disclosure policy. And in this document, we include bad practices around open source software. We deem it a bad practice to include open source components with known exploitable critical vulnerabilities, and we include a list of recommended action that we believe every software manufacturer should take. That includes things like maintaining provenance data through a software bill of material for your open source dependencies, keeping them regularly updated, as well as using an artifact mirror to ensure that you can inspect updates to open source components. So we need your help to get this right, because we know we alone are not going to, in our first pass, get everything right. So please do take a look at this document, scan that QR code, provide us feedback. We want to see how we can really articulate at a clear-cut level what software manufacturers should and shouldn't be doing in 2024. And with that, I appreciate everyone coming to this talk. I'll be around after. I also have a panel around some of the policy implications of open source software, and hope that we can all connect and push forward to achieve a secure by design future. Thank you.